Sum of two integers. Given two integers a and b, return the sum of the two integers without using the operators plus and minus. Example 1 is 1 plus 2 is 3 and 2 plus 3 is 5. So this is a very simple problem, but and actually the solution is quite simple too, but it looks like a lot of people don't know how to do this, and it's actually a really interesting problem that demonstrates a lot of knowledge around binary operations. So yeah, let's have a look. I prepared a couple of slides to understand this. So how do we do this? The idea comes from this. If you add two numbers, the addition of these two numbers is the same as a plus b without carry plus carry. So as an example here, we have 6 plus 8, and 6 plus 8 without carry is 4, because 6 plus 8 is 14, and then that 10 being the carry, without carry is 4, and the carry is, like we said, 10. And so a plus b becomes 4 plus 10, and therefore a plus b is 14. And similarly, we will see why we consider this in the first place, but this works very similar, exact same way for binary representation of numbers too. So here, say a is 10 and b is 30. Binary representation of 10 is 0, 0, 1, 0, 1, 0, and for 30 is 0, 1, 1, 1, 1, 0. And when you go a plus b without carry, it works similar. You just add each digit. So the first one would be 0, and the second one, 0 plus 1, would be 1, and the second one, 1 plus 1, would be 1, 0. But here we're saying without carry, so we'll just carry 0, and we continue this way until the end. So we end up getting 0, 1, 0, 1, 0, 0. And this happens to be, if you see it, it's 1 when only a or b is 1, but it's 0 if they're both 0 or if they're both 1. And in other words, to say this is XOR operator, which stands for OR exclusive, or exclusive OR. And so this is a plus b without carry, and the carry bit is simple. So what happens is we look for those digits that have both ones, and when they're both ones, the place next to this digit right here becomes 1. So for example here, we have the third column, we have both ones. So the second column, which is the second is left to the third, becomes 1. And we have that in the fourth column as well. And we can see that this is like a AND operator, but with the -1 placement. So what happens is, while carry is not 0, we carry out this operations. A plus b without carry, a exclusive OR b operation, and then a and b operation with the -1 placement, and then we continue this until the carry is not 0, and the final answer is the summation. So yeah, so the whole thing lies in the fact that once we convert it to the binary representation of the numbers, we actually don't need plus or minus. All we need is these exclusive OR operation and the AND operation. So how do we code this up? Actually, that is the easy part. So here we have the getSum function a and b. So we will say while b is not 0, we'll continue this following operation, and this following operation is equivalent to adding the a plus b without carry bit plus the carry bit. So first, let's compute the carry. Here, the carry is So when you add just one AND sign, that computes the AND operation bitwise. So you do that, and let's update A to B. So that's the exclusive OR operation, and B to B carry. And then once that while loop is over, we'll return A. Yeah, so we can see that this is how we solve it. The acceptance rate is just above 50%. I think it's quite a simple problem, but really interesting, and it demonstrates your understanding of the binary operations as well as the Boolean operations. So I think it's a really cool problem.